Bismillahirrahmanirrahim. Dear students, today's our topic is mole concept. This mole concept acts as a bridge between two worlds. One world we call as macroscopic world and another one as atomic world. That means if we have a large sample of any compound, the number of molecules within that compound, what is the number, we can know that by means of a concept. That concept is mole concept. First of all, we know we have seen this number. This number 6.022, or you may write 23 here, into 10 raised to the power 23. We have seen this number from our 9th class. This number we call as Avogadro constant, denoted by Na. This is one of the largest numbers. It is difficult to comprehend. Now I will take here some examples so that you may be able to understand how large is this number. First of all, if we will take the water drops, their number equal to this 0.22 into 10 raised to the power 23. If we multiply this number by 40, then this number is the number of all water drops present in all oceans on the surface of Earth. After that, if I will take the number of stars in our galaxy Milky Way, this one Milky Way, if such galaxies in number, they are equal to 6 million galaxies of the same size as the size of Milky Way. The number of stars in Milky Way multiplied by 6 million such galaxies, that will give us the number that is having value equal to this. After that, I will take this example. We know the speed of light, that is c, that is approximately equal to 3 into 10 raised to the power 8 meter per second. If this extreme speed of light will travel, then it will travel such number of miles, means number of miles equal to 0.23 into 10 raised to the power 23. Such miles will be covered by light in 102 billion years. So the extreme speed possessed by light, if light travels such a number of miles, then even this light will take 102 billion years to cover these number of miles. So one of the biggest numbers used in every calculation in atomic world. Every student who is interested in the fields of atomic sciences, material sciences, chemical sciences must have the knowledge of this concept, mole concept. Now first of all, mole is a Latin word. Mole means this one used in SI system. We denote that by means of this. It is a Latin word, means huge pile. Again, its meaning is a large number. Large number. After that, its definition, I may give the definition of this mole. Mole is equal to number of carbon atoms. Number of carbon atoms present in 12 gram. That means 0.012 kg of carbon 12. The number of carbon atoms which are present in 12 gram of carbon, we call that number as mole. We may define this mole in this way also. It is the amount of any substance. Amount of substance which contains as many entities as or number of carbon atoms number of carbon atoms present in 12 gram of carbon. So in this definition we have used entities word. Entities means they may be now number of atoms. In case of an element, they may be number of atoms. And in case of compound, they are number of molecules. Number of molecules. And in case of any ionic substance, they are number of ions. Number of ions. And in case of electricity, we can say they are number of electrons. And in a nuclear field, we may say number of protons. So, whatever be the substance, the number equivalent to the number of carbon atoms which are present in 12 gram of carbon, we call that as mole of that substance. Now, taking these examples, I will take oxygen atom. Oxygen atom, if we have the sample equal to 16 gram of oxygen atoms, then within this we can say within 16 gram there are 6.022 into 10 raised to power 23 oxygen atoms. Similarly, if I will take 32 gram of oxygen molecule, then if the number equal to 6.023 into 10 raised to power 23 number of oxygen molecules, number of O2 molecules, they are present in 32 gram of oxygen. Similarly, if I will take 23 gram of sodium metal, this one, then within this amount of sodium, there are 6.022 into 10 raised to power 23 sodium atoms. Now, if I will take this, for example, water, I will take it is 18 gram. Then in it is 18 gram, there are 6.022 into 10 raised to power 23 water molecules. If I will take now this one, carbon dioxide, if I will take its mass equal to 44 gram, then within 44 gram of carbon dioxide, there are 6.022 into 10 raised to power 23 carbon dioxide molecules. Similarly, if I will take this formula, we know this is an ionic compound. In case of ionic compounds, we take formula units. We take formula mass. If number of units of NaCl within a sample that is equal to 23 plus 35.5, that is equal to 58.5 gram of sodium chloride. If we will take this amount of sodium chloride, then within this amount, within this mass, there will be 6.022 into 10 raised to power 23 sodium chloride formula units. In case of, you know already this point, that in case of ionic compounds, we cannot use the term as molecules. We use molecules in covalent compounds. So in case of ionic substances, we use formula units. Similarly, if I will take this example, Na2SO3. So we can calculate its amount. sodium, that is 23 into 2 plus sulfur, I will take approximately that equal to 32 plus 3 into 16. This one total taken, such grams if taken, within that will be 6.022 into 10 raised to power 23, these formula units. So in this way we can define this number we call as Avogadro constant. This number of entities present in any sample, we can call that as that is the 1 mole of that substance. So 23 gram of sodium contains number of sodium atoms, that is equal to 6.022 into 10 raised to power 23, or 23 gram of sodium positive ions contains number of positive ions of sodium equal to 6.022 into 10 raised to power 23. Similarly, 16 gram of oxygen atoms contains 6.022 into 10 raised to power 23 oxygen atoms. Now this 32 gram of O2 molecules, means 32 gram of oxygen contains 6.022 into 10 raised to power 23 oxygen molecules. Similarly, if we will take this water, we will take 18 gram of water, 18 gram of H2, then that contains 6.022 into 10 raised to power 23 molecules of water. Molecules of water. Similarly, in case of this substance, if we will take 180 gram of glucose, 180 gram of glucose, then that contains 6.022 into 10 raised to power 23 glucose molecules. So in general, they may be ions, they may be electrons, they may be molecules. All these ions, molecules or atoms, we call in general, we call them as entities. So we have written entities in the definition. That means they may be electrons, they may be protons, they may be atoms, they may be molecules, or even they may be ions. Now this mass, we call this number as mole, such a mass called as molar mass of that substance. So molar mass of sodium, this one we call as molar mass of sodium. Similarly, this we call as molar mass taken in grams, means 16 gram per mole. It is the molar mass of oxygen atoms. This one 32 gram per mole, means it is the molar mass of oxygen molecule. Just like this, 18 gram per mole means molar mass of water molecules. Means water molecule is having molar mass equal to this. Now we are able to say this point, in 18 gram of water there are 6.022 into 10 raised to power 23 water molecules. In case of calculating molar mass, molecular mass or atomic mass of any substance, we can use a reference. You know already that in every kind of physical measurement, we first of all must have a reference. Similarly, in case of determining atomic masses, we have a reference. That reference is carbon 12. Within this, we can take this value 1 AMU. 1 AMU, now noted as 1 U. Atomic mass unit, now here unified mass. it is equal to 1 by 12th of 1 by 12th of mass of one atom of carbon 12. Mass of one atom of C12. This is equal to 1.66 into 10 raised to power minus 24 gram, or you may take it in kgs, that will be 1.66 into 10 raised to power minus 27 kg. This we use as a reference in determining atomic masses, molecular masses, or molar masses. So with respect to this, if any element we take, how heavier or how lighter is that element in comparison to this, we can call that mass as it is atomic mass. For example, if I will take hydrogen atom. Hydrogen atom is having mass equal to 1.67 into 10 raised to power minus 27 kg. So we will convert this mass in AMU. First of all, this is in kg. For example, I will write here 1.67 into 10 raised to power minus 27 kg. After that, I will write here this unit factor. Here, this one 1.66 into 10 raised to power minus 27 kg again. That equal to 1 AMU or 1 U. So after that, this kg and kg will cancel with each other. Then dividing this term by this term, here is a value that is 001.0078. I will write this, or approximately I will write 1.008 AMU. This is the atomic mass of hydrogen atom. Means hydrogen atom is having mass equal to this. This is written in this way instead of AMU. Now the more recent term, that is U, unified mass. This now replaced by U. So 1.00 U is the atomic mass of hydrogen. Now we will take this one as hydrogen molecule. Its mass means mass of 2 atoms of hydrogen. That will be now equal to 2 into 1.008. That is nearly, I will write here approximately, that equal to 2U. So molecular mass of hydrogen molecule is equal to 2U. Similarly, we will take this one, water. In water, we know there are 2 atoms, hydrogen atom and oxygen atom. These 2 hydrogen atoms, they have mass equal to 2U. After that, oxygen atom calculated in this way, that is having mass equal to 16U. So the total mass will be equal to 18U. In this way, 18U, this one being the molecule, we call this as molecular mass of water. Similarly, if I will take carbon dioxide molecule, then carbon is having atomic mass of 12U. After that, 2 oxygen atoms, so 2 into 16. That will be equal to 12 plus 32. And this addition is equal to 44. If we will write 44, here U will 44, then that is the molecular mass of carbon dioxide. Now, if we will write in this way, 44 gram, it is the molar mass. It is the molar mass, means within this amount, there are 6.022 into 10 raised to power 23 carbon dioxide molecules. So this mass we call as molar mass, and we write with it this gram per mole. Similarly, if I will take this one, 18 gram per mole, that is the molar mass of water. Similarly, if I will take 180 gram per mole, then that is the molar mass of glucose molecule. So now you may be knowing this point. If we will keep U with the mass of any element, then that is the atomic mass of that element. If we will keep U with the molecular mass of any molecule, then that is the molecular mass of that molecule. If we will take the mass in grams per mole, that means that is the molar mass of that substance. I will take here some calculations involving this mole concept. What is the number of? For example, I will take this problem. What is the number of carbon atoms? Number of carbon atoms present in 1 carat of diamond. 1 carat of diamond. If given this one, 1 carat is equal to, given 1 carat equal to 200 mg, milligrams. So we will now determine number of carbon atoms present within 200 milligrams of diamond. First of all, we know this 200 mg means 200 mg is equal to 200 divided by 1000 in grams. That is equal to, after 3 places decimal, 1, 2, 3, 0.2 gram. This is the amount of diamond in grams. Now after that, number of moles, we will use this formula. Number of moles is equal to mass in grams of that substance divided by molar mass of that substance. So in 1 carat of diamond, there are 0.0166 moles of diamond. Now after that we know this. 1 mole contains number of entities. They are equal to 6.022 into 10 raised to power 23. Now number of such moles are equal to 0.0166 moles will contain number of atoms equal to 0.0166 into 6.023 into 10 raised to power 23. This calculation multiplying this by this, that is equal to 1.003 into 10 raised to power 22, means there are approximately 10 raised to power 22 carbon atoms present in 1 carat of diamond. Second example I will take here. If carbon atom is having mass equal to 1.99 into 10 raised to power minus 26 kg. Then what is the mass of carbon atom in AMU? First of all, we know this point. 1 AMU, 1 U is equal to 1.66 into 10 raised to power minus 27 kg. So within this relation we will use this 1.99 into 10 raised to power minus 26 kg. After that we will multiply this one by this 1U or 1 AMU divided by 1.66 into 10 raised to power minus 27 kg. Kg and kg will cancel. So after that, multiplying this with this and dividing by this, we can obtain nearly a value equal to this, 12U or 12 AMU. So this is the atomic mass of carbon, means mass of one atom of carbon. Similarly, I will take this example. If one oxygen atom is having weight equal to mass equal to 2.67 into 10 raised to power minus 27 kg, Then what is the mass of oxygen atom in AMU? Again proceeding in the same way, 2.67 into 10 raised to power minus 26 kg. This one is minus 26 kg. After that here I will write 1U. 1U is equal to 1.66 into 10 raised to power minus 27 kg. This is now equal to 2.67 into 10 raised to power minus 26. After that, this one in the numerator, that is now equal to 10 raised to power 27 divided by 1.66. So that is equal to 2.67 divided by 1.66 into 10. 27 minus 26, that is equal to 10 raised to power 1, so multiplied by 10. That is nearly equal to 16. Means the atomic mass of oxygen atom, that is equal to 16U. Now let us take this example. Suppose we have a glass of water. That glass of water, this means its mass is equal to 180 gram. Now the number of molecules within this glass of water. We know number of moles is equal to mass in grams divided by molar mass. So here mass in grams, that is equal to 180 divided by molar mass of water, that is equal to 18. So this is equal to 10. 10 moles of water are present within this glass of water. After that, we know 1 mole is having number of molecules equal to 6.022 into 10 raised to power 23. So within 10 moles, the number of molecules will be, within 10 moles, the molecules will be this one multiplied by 10. So this, say 10 into 6.023 into 10 raised to power 23. Here power 10 raised to power 1, 23 plus 1, that is equal to 24. That is 6.023 into 10 raised to power 24 water molecules are present within a glass of water which weighs equal to 180 gram. After that, let us take this example. Let us take a glucose pack. For example, this is the pack of glucose. Its weight I will take for easier calculations as equal to 180 gram. So number of moles again, that is equal to mass in grams divided by molar mass. This one. Now mass of grams within this pack, that is equal to 180 divided by molar mass of glucose, that is equal to 180, because glucose is having this formula C6H12O6. We can calculate its molar mass just like this: 6 into 12 plus 12 into 1, after that plus 6 into 16. This is equal to 72, this one plus this one, 12 ones are 12, this one, 6 6 are 36, 6 ones are, that means 96, and this is equal to 180 gram. That means glucose is having molar mass 180 gram per mole. So number of moles within a pack of 180 gram of glucose, that is equal to 1. After that, we know 1 mole is having number of molecules. They are equal to 6.023 into 10 raised to power 23. That means such a number of molecules of glucose are present within a pack of glucose whose mass is 180 gram. Let us take the example of number of carbon atoms in a sharp pencil dot. If we have a good analytical balance that is capable of measurement of the mass of this sharp pencil dot. Suppose the mass of this sharp pencil dot that is equal to 0.00024 gram. 24 gram, which is equal to, I will write in this way, 24 into 10 raised to the power 1, 2, 3, 4 and 5. 10 raised to the power minus 5 gram. After that we know number of moles is equal to mass in grams divided by molar mass. So mass in grams is equal to 24 into 10 raised to the power minus 5 divided by molar mass of carbon, that is equal to 12 gram per mole. 12 gram per mole. So this will be equal to 2 into 10 raised to the power minus 5. These are the number of moles present in the pencil dot. Now we will determine the number of atoms. So the number of atoms, we know 1 mole is having number of atoms equal to 6.022 into 10 raised to the power 23. These are the number of atoms in 1 mole. So the number of atoms in 2 into 10 raised to the power minus 5 moles will be equal to these moles into number of atoms per mole. They are 6.022 into 10 raised to the power 23. Number of atoms per mole. Atoms per mole. So multiplying this one with this, that will be equal to 440, and after that this one to that into 10 raised to the power, here will be 18. This one 23 minus 5, that is equal to 18. I will write this 1.2044 into 10 raised to the power now 19, because I will write 12 as 1.2 into 10. So these are the, approximately I will write this one, these are the 10 raised to the power 19 carbon atoms are present in the sharp pencil dot. So in this way we can apply this mole concept. We can apply this in this way, so that we can create a link between macroscopic world and microscopic world. Now I will take, suppose this example. For example, our body, the weight of our body is equal to 72 kg. This one is the weight of our body. After that, that is equal to 72 into 10 raised to the power 3 grams. So number of moles, if supposed to be made up of carbon atom, that all of you know that that is not true. In our body there are many different atoms present. I suppose within this mass there are only carbon atoms. So number of moles is equal to mass in grams, that is equal to 72 into 10 raised to the power 3 divided by this one 12 gram per mole as molar mass of carbon atom per mole. So these are the grams. This one is equal to 6 into 10 raised to the power 3 moles. So these are the number of moles of carbon present in our body. After multiplication with this number, 6 into 10 raised to the power 3 multiplied by this one, 6.022 into 10 raised to the power 23. That will be equal to 6 2s are 12, 6 2s are 12, 13, 6 1s are 6 6s are 36. After that, this one will be equal to 10 raised to power 26. So taking this one as 3.6 into 10 raised to power, that will be now equal to 27. These are the number of carbon atoms as per my supposition present in our